this lesson, we are going to continue looking at one-step equations. And we've already started looking at the one-step equation. So if I had 2x equals 6, we knew the inverse operation to multiply would be to divide both sides, right? Or if I had x over 2 equals 6, the inverse operation to dividing is to multiply using brackets, and we get x equals 12. Or the inverse operation to adding 2 is to subtract 2 to both sides, and the inverse operation to subtracting would be adding 2 to both sides, etc. So what happens now when we have fractions in our algebra? For example, 1/3 of x is 12. What is a third of x? What is a third of a number to equal 12? What is that number? Again, we can go by inspection, or we can properly learn these steps so when we get to multi-step, we have the steps to follow. So basically, whenever I have a fraction multiplied by a variable, like I showed before, multiplying a third by x is the same as multiplying by x over 1, which is 1 times x over 3 times 1. So whenever you have a fraction multiplied by x, the x can go in the numerator. Right? So this is the same as 1x over 3, or x over 3. That's one way I can do this. So now that I have created it with x in the fraction, I can say, okay, well, the opposite of dividing by 3 is multiplying by 3. Whatever I do to one side, I do to the other. And now I have those cancel, and I get x equals 36. All right? Again, if you have a negative out front, the negative can either go to the numerator or the denominator. In this case, sometimes it's better to go numerator, sometimes denominator. In this case, it's better to move it with the denominator because then I can isolate x in one step. So now that I've moved the negative down with the 4, I can say the opposite of dividing by -4 is multiplying by -4. And again, the golden rule of algebra, whatever I do to one side of the equal sign, I must do to the other side of the equal sign. I cancel, and I'm left with x equals -20. I keep my equal sign lined up. I write the answer to this below it. So if the x is on the left side of the equation, it stays on the left. If there's no x on the right side, it stays on the right. Okay, so for example, over here, I have 1 over 5x, which I would write as 1x, or x over 5. Do you notice the x is on the right side of the equation? It just stays there. It's okay. It doesn't matter which side the x is on, right? I can switch it all later if I need to. So, the opposite of dividing by 5 is multiplying by 5. Whatever I do to one side, I do to the other. Those 5's cancel. The x stays on the right side of the equation, and this becomes -30. Since I have brackets, I'm remembering I'm multiplying. You could put double brackets if that helps to remember you're multiplying. Okay? And again, it's okay to say -30 equals x. If you really want your x on the other side, now is the time I would move it, right at the end only. -30 equals x is the same as x equals -30. What happens if your fraction is something like this? 2 over 3x. I could write it like this, right? Move the x with the numerator, that's fine. So what's happening to x? X is being multiplied by 2 and divided by 3, because a fraction is, I'm dividing it into 3 equal pieces and taking 2. It's really 2 operations in one. You are multiplying and dividing. So when we're undoing, we need to undo both. What's the opposite of multiplying by 2? Well, that's dividing by 2. What's the inverse of dividing by 3? Oh, that's multiplying by 3. And so you can see the reciprocal of the fraction gets you to 1x. By multiplying by a reciprocal, you get a product of 1. So if you have a fraction being multiplied by your variable, you multiply by the reciprocal. And again, whatever you do to one side, you do to the other. And you can see that those cancel, and so you're left with x on the left side. What are you left with on the right side? What is 9 times 3 over 2? Well, that's 9 over 1 times 3 over 2. I don't see any canceling, so it becomes 27 over 2. Right? Or you could change it to a mixed fraction, which goes in 13 times and 1 left over. Okay? So if it's a fraction in front of x, you multiply both sides by the reciprocal to undo and be left with 1x. Okay? This one we have done already, so we now know that if we have a negative in front, we can just move that negative to the bottom, right? And now we can multiply both sides by -2, and that will cancel, and I'll be left with x is -36. Let's move over to this one. Again, here we have a fraction, 2 over 5x. So to undo 2 over 5, I multiply by the reciprocal, so I put brackets to multiply. Whatever I do to one side, I must do the exact. So whatever I've done to the left side, I must do to the right side. Right? That keeps it balanced. This left side, everything cancels, and I'm left with x on the left side. The right side, ooh, I see canceling. 1, 2, I can reduce. 3 times 1 is 3. 2 times 2 is 4. Oh, x is 3/4. In other words, 2 over 5 times 3 over 4 equals 4 over 10, or equals 3 over 10. Let's write a few more. Here, most people multiply by the reciprocal of the fraction they first see. Be careful. You always have to identify where the variable is because you have to get that variable by itself. So it's whatever is happening to the variable is what you're trying to undo. The variable is being multiplied by 5 over 12. So you have to choose the reciprocal of 5 over 12. That's the key, because those will cancel to leave you with n, right? Those will cancel to leave you with n. So whatever I do to one side, I must do to the other. Right? You just write it with brackets on both sides. Now again, I look for canceling. Oh, I can divide by 3. I can divide by 3. So that's all I can do. So I get 32 over 25. I can leave it improper, or I can change it to 1 and 7 over 25. Okay. Same thing here. I have to look where x is. Oh, x is right here. So I have to undo multiplying by 9 over 10. So the inverse of multiplying by 9 over 10 is multiplying by the reciprocal, because now you're multiplying by 10 and dividing by 9. That will cancel it. So whatever I do to one side, I do to the other. Those cancel to leave me with x on the right-hand side. On the left-hand side, I put 3 over 1 there. Oh, I see canceling. I get 10 over 3, or 3 and 1/3. Right? What happens if it looked like this? Right? I know the opposite of multiplying by 3 is dividing by 3, but how do you go 9 over 10 divided by 3? Kind of gets messy. So what would I do with something like this? Well, I can just use my reciprocal thing again. The only difference is my reciprocal of 3 over 1 is 1 over 3. Right? So if this is a fraction over here, instead of dividing by 3, we all know that dividing by 3 is the same as multiplying by its reciprocal. So I can multiply by its reciprocal. Whatever I do to one side, I do to the other. So sometimes you have to make things work for you. Rather than trying to have a fraction divided by 3, we wouldn't do that in algebra. Instead, we would multiply by the reciprocal. That looks neater and nicer. So I end up with getting x equals, and again I can cancel, oh, x is 3 over 10. All right, so that is a continuation of one-step equations in which we have fractions in that one step.